Hello class and welcome back to another episode of Sketch Science. Have you ever wondered why opposites attract or why we even say that? Well, the answer is magnets. But what is a magnet? Magnets, to be completely honest, are just pieces or objects that attract or pull other objects that contain iron. That's what a magnet is. It pulls in objects that contain iron. Now, it's called ferrous material that keeps iron in. The reason it's called ferrous, if you look at this Fe right here, if we were to go to the periodic table, Fe is the symbol for iron. Ferrous material, Fe for iron. Iron objects are ferrous. Now, magnets can also pull on other things like cobalt and nickel, but for the most part, it pulls on materials that contain iron. That's what a magnet does. Now, how do magnets work? Well, magnets emit something called a force. A force, in this case, is magnetic force. Now, magnetic force is the push or pull exerted by a magnet. So it's push or pull. Magnetic force, it can either, depending on the polarity, the poles, which we'll get into in a little bit, it can either pull iron towards it or push it away. Now, the strength of magnetic force varies, but very strong magnets can only attract or repel certain materials. So it can be the strongest magnet in the world, but if you put a plastic fork to it, it's not going to hold. Meanwhile, it could be the weakest metal in the world and still stick to any magnetic object it wanted to. That is the idea of magnets. Their force can only be applied to certain other objects, be them other magnets or ferrous materials. Moving on from that, when you think about a magnet, we're going to talk about poles now, or actually we're going to go into domains. Domains would be a better place to start before we get to poles. So domains. What is a domain? Well, a domain in one term is an area that belongs to something. When it comes to magnets, it's what direction the magnetic charge is facing. So it's what direction the magnetic charge faces. It can be in any direction. All iron has domains in it. So you could look, if this was a piece of iron, domains are like slices of that. They're broken off pieces. Each piece has its own domain. So if you had all these domains in a piece of iron, one could be facing this way. One could be facing this way, that way, this way, that way, up, down, left, right. They can be every which direction. That piece of metal is not going to be magnetic. It's not, because the domains are all facing in random directions. Each one of those has some form of magnetic pull to it, but if they're going in every single direction, that pull's never going to be strong enough to pull anything in. Meanwhile, if you look at a magnet, if you took another piece of iron with all these domains in it, and every single one was facing in the same direction, well, you have yourself a magnet. Magnets are caused by all of the domains, all the magnetic charge facing in the same direction. That is a magnet. all the domains facing the same way, it has an electric, or it has a magnetic charge, not necessarily electric. You can create a magnet with electricity because it's all the flow of electrons. That's what magnetism is. Now, remember, this is a magnet, this is not. The cool thing about domains is in non-magnetic material, the domains can change depending on what they're put next to. So you can have that same piece before. We're just going to do rectangles now. You can have this same piece over here with all these domains going in different directions. But if you were to put it next to a magnet where all of its domains are facing the same direction, if you were to touch it with this magnet, so if you were to put it against a magnet, all of these domains would now switch to being that direction. So all of these arrows would go to face the same direction as the magnets. That's how these metals work. That's how metal's attracted to it. All of its domains, all these electrons in it, all start being pulled to the same direction, the same flow that the magnet has. So this piece right here would change all of these arrows to being the same direction as the magnet. Just by being next to it. And that's how it gets pulled in. So, domains can be any which direction in any non-magnetized ferrous material. But as soon as you expose them to a magnet, all those domains line right up. Now that's what we call a temporary magnet. So if you line all the domains up using another magnet, now all these domains are lined up. So it's magnetic. It can pull in another piece and line its domains up. But if you were to take this other magnet away, if this got removed, all of these arrows would go back to facing any direction they wanted. It's like attention spans. You have it at 1 second, but as soon as you take your foot off the gas, they're gone. Temporary magnets, yes, they can be magnetic for a time because they're next to another magnet, but as soon as you take that other magnet away, it's gone. That's the idea of if you had a magnetic screwdriver. So if you had this magnetic screwdriver here, and you took a screw, when this magnetic screwdriver goes into the screw, it becomes a magnet itself. So if the polarity, or if the domains were all facing this way, all of the screws would go that way as well. So you could put another screw on the end of this one. And it would do the same thing. As long as you kept that magnet connected to the others, it would always keep going. It would create more and more temporary magnets as you went. Eventually the charge might get too weak to carry anymore, but you can create temporary magnets using permanent magnets, which always have their domains facing the same direction. Permanent magnets can be made a bunch of different ways. Now a permanent magnet can either be an object that's naturally occurring, they can be natural, or they can be made using electricity. So they can be natural, they can be made with electricity, they can be made by radiating the metal, so radiation. All of these things can be used to create magnets. If you think about it, in an X-ray machine, it uses radiation and magnets to take pictures of different things in your body. That's how it works. In the airports nowadays, they have those big full-on body scanners. They use magnets, metal detectors, all these things, radiation. So natural, electricity, radiation. these are the way permanent magnets can be made. Permanent magnets will keep a charge no matter what. So you have temporary magnets, permanent magnets, domains. What does this all mean? It means that metal, ferrous materials, remember Fe, iron. Fe is iron. That is what magnets pull in. Magnets have domains. Domains are the direction the charge faces, or the direction of force. Every ferrous material has domains, but only magnets are aligned. The rest of them are all random. They're all over the place. They don't pull things in because they can't decide which way they want to go. You can have temporary. Temporary magnets are pieces of iron or pieces of metal I can't spell pieces. So we're just going to say objects that become magnets when exposed to other magnets. And then you have permanent magnets, which are objects either natural or man-made that hold their own charge. Their domains are always lined up due to either electricity running through them, radiation, or naturally occurring. So these are the main things to take away from this lesson. Iron, ferrous materials, Fe, that is what most magnets attract, or all magnets attract. Some of them also attract cobalt, nickel, a couple other metals, but for the most part, it has to be a ferrous material, iron-based. Domains is the direction of force that a ferrous material has. They can be in all different directions if they're not a magnet, but if they are, those are all lined up. The domains are all facing the same way. Temporary magnets. Any piece of ferrous material that when exposed to a magnet lines up its own domains, so it becomes a magnet as well, as long as that other magnet is still there. As soon as you take that magnet away, that's why it's called temporary, that charge goes away too. And then finally, permanent magnets. Naturally occurring, some objects, when they form in nature, lodestones is an example. They form as a magnet already. You don't have to do anything about it. It will already be a magnet. But we can make it through putting an electric coil around a piece of ferrous material, or putting radiation into a piece of material, depending on what it is, to create magnets, permanent magnets. Now, we're going to pick this back up in another video, but if you have any questions about this video, any more clarifications you need, please don't be afraid to ask and leave a comment. Now, be sure to like the video, especially if you need to come back to it. That way it's a lot easier to find, and I know that you're actually supporting the video. Also, with the comments, let me know what I could do better. And as always, subscribe. That way, you can, one, find the channel easier, quicker. If you don't like the video, you can find the video faster if you subscribe to come back to the channel. And it also helps me, once again, to know who's all watching so I can best take care of my audience. Now, keep those things in mind. Keep this video in mind. Think about it. Ask any questions you need. And I will see you next time.